Okay, everyone, I'm going to do an example for number 4 on the exam, but I am not going to do the same exact problem. I'm going to do one just like it, just different numbers. So I'm going to change it to, instead of 1 foot away from the wall, 3 feet, and instead of it being a maximum of 64, I'm going to say the maximum is 25. And instead of it landing at 17 feet away from the wall, let's do, what did I say, 13. Let's do 13. Okay, so I'm going to use Desmos to do a lot of this. Sarah launched a water balloon from the ground standing 3 feet away from a wall. The balloon reached a maximum height of 25 feet, and then it hit the ground 13 feet away from the wall. So we need to set up our graph in Desmos. This question, in order for you to get full credit, says create a graph to represent the scenario. The graph should include at least the x and y intercepts and the vertex. A complete graph consists of labels, so we need to label our axes, ordered pairs for each point, the function, appropriate domain, and range. So I'm going to change the labels. Well, mine are already in there, but you're just going to click on this little wrench, and you're going to make your x-axis the time. So the balloon is in the air for a matter of seconds. Although I don't think it even says that. Oh, you know what? I take it back. I was thinking this was seconds, and it's not. It's actually feet. This is the amount of feet from the wall. I did that when we did this balloon problem in class. I'm so used to the x-axis being time. So the x-axis is your horizontal feet from the wall, and then the y-axis is your height, how high it is. So we should put maybe, well, let's just put horizontal feet from wall. Okay. So I have my axes labeled, horizontal feet from wall, height, and it gives me 3 points. It says that she's standing 3 feet away from the wall. So this is 3, 0. And it does say in the problem that we should have everything labeled with the ordered pair, and we should label that it's the x-intercept or the y-intercept or the vertex. So I'm going to put x-intercept and also rewrite the point so that it shows up on the screen. Okay, so for me, I'm saying she's starting 3 feet away from the wall. The vertex is going to be something 25. I don't know what that x coordinate is going to be just yet, but it's going to hit the ground 13 feet away from the wall. So this is going to be 13, 0. Okay, and you can probably see where the vertex is going to be. It's going to be right in the middle of those 2 points. If your window is not a good window, maybe you're way, off like this, you can, of course, just drag the graph around, but that doesn't mean you're going to have the max and min. So I'm adjusting my x-axis so that I can see both x-intercepts and I can see my y-axis clearly. So my x-axis minimum is negative 2.267. So I think a minimum of negative 2, negative 3 is going to be fine. The maximum is 19.48. Anything above that second x-intercept is going to be good. I might even bring that down a little bit to 16. Okay, so I changed my x-min and my x-max a little bit, and then my y-min, my y-max. You want your y-min to be a negative value because you want to see your x-axis, and we're supposed to include the y-intercept on here, so we might actually do that. I might do that now that I'm doing this video. My y-max is on 65, but I really don't need it to be quite that high. My highest point is 25, so I think I'll change that y-max to 35. Now, you can obviously just mess around with your graph and probably get a decent graph, but sometimes it does help to change the max and the min to fit your graph a little bit better, and then you can just slightly adjust it. Okay, so I'm looking at this. My balloon is launched at 3, and it lands at 13. So I'm just going to kind of look at this and say, what's right in the middle of 3 and 13? I can kind of look and see where the middle of that is. Now, you might be looking at yours and saying, I don't know where the middle is. Okay, just take your two x-intercepts and add them together, divide by 2, average them together. So for me, that gives me 16 divided by 2, which would be 8. Okay, so I know that my vertex is going to be 8, and then I know the high point is 25. So the balloon goes up, and then it comes back down. So 8, 25 is my vertex. And I'm going to label that vertex and then rewrite the coordinates. So I got 25 because it told me that the maximum height is 25. So my vertex, I found the x-coordinate by averaging those two x-coordinates together, x-intercepts together to get the x-coordinate of the vertex, and then I know the high point is 25. Okay, so now I need a graph that goes through those 2 points. So we've done this. We didn't have a Khan assignment exactly like this, but we've done this. If my x-intercepts are 3, 0, and 13, 0, then my factors are going to be x minus 3 and x minus 13. Now that doesn't mean that's the equation, because you can have a stretch or a shrink factor out in front here, and you have to figure out what that is. But that does mean that you're going to have factors of x minus 3 and x minus 13. So I'm going to start out by typing that in. Now that does go through 3 and 13, but it doesn't go through the vertex. Now you can kind of probably figure out what this is pretty easily by just putting some different numbers right here for A. But if you would like to solve this algebraically, you could just take your vertex and plug it into this equation. Remember, this is just another way of y equals your equation. So I'm going to plug in 8 for x and 25 for y. That's going to give me this. 8 minus 3 is 5. 8 minus 13 is negative 5. I'm going to multiply 5 times negative 5. And then I'm going to divide both sides by negative 25. That's going to give me negative 1. So you probably could get that, just figure out what that value is just from kind of messing around with your graph in Desmos. But that would be a way to solve it algebraically. So then my equation is, so that's A, this is my equation. So let's type that into Desmos. And it should go through your two x-intercepts and your vertex. Okay, so let's see, what else do we need to do? We've got a graph. We've got our x and y. Oh, we don't have our y-intercept. I kind of skipped over that in class. We could add that in there. It's not that hard to do. Also, domain and range. Okay, and we need a table. The y-intercept is just, I'm going to adjust my y-min so that I can see it. It doesn't have any meaning in terms of this graph. Okay, I made my y-min negative 50, and I can see my y-intercept is right here at 0, negative 39. It's not that hard. Let's just go ahead and put that in there. 0, negative 39. That's our y-intercept. 0, negative 39. Okay, so we've got our y-intercept, we've got our x-intercepts, we've got our vertex, we've got our equation, domain and range. Okay, let's click behind the equation. So I'm clicking on my line 4, and I'm going to click this little settings wheel and enter a table. But it doesn't put the values that I'm interested in. I'm actually not interested in -2 or -1. I'm not even really interested in 0, 1, or 2 because this balloon, water balloon, is not launched until she's 3 horizontal feet from the wall. So I'm really only interested in 3. Whoopsie. Let me try that again. I'm interested in 3, 4, 5, 6, until it hits the ground. So I'm entering each horizontal foot from the wall. Okay, there we go. So we did very little with domain and range. Domain is just all your x values that make sense in terms of this problem. So I just listed, I'm going to use the marker here and I'm going to highlight this. These values are my domain. There they are in the table, and here they are on the graph. That is the domain. I wish there was a way to type something on the graph, but anyway, we'll type over here. Okay, and then the range, these values are the range. And that looks like this on the table, and it looks like this on the graph. If that is confusing, if you don't understand that, I'm going to say just don't worry about it. It's one small piece of this problem, and it's really not the end of the world if you don't get that. But I am going to, whoopsie, I'm going to insert, let's see, okay, I'm going to come down here and I'm going to type domain, whoops, I'm going to insert a note. So I click on this plus sign. Oh. Okay, hold on a second. Okay, where were we? Okay, I was typing in here, so I clicked on the little plus sign and I put note. Let me erase these, everything. Okay, I'm going to enter the domain. Oh, whoops. Let me try that again. note, then we can type in a note. And I'm using brackets here for a reason. 3, my domain is 3 to 13. Range is 0 to 25. If you understood domain and range, you could try typing that in. But if that's just something that's really throwing you off, just don't worry about it. Okay, so domain, range, what else do we need? Let's get this out of the way. Domain and range, we wrote the function, we did the table, and your table should have your x and y intercepts and your vertex. So make sure that it has, like I did. I made sure it had the x intercepts and it has the vertex on there. Okay. And then this last part says, identify how you see the x and y intercepts and the vertex in the table, in the graph, and in the equation. Hint, you may want to rewrite the equation in equivalent forms. Okay, so we have already addressed how we can see the x-intercepts in the graph. We have everything on the graph. We have everything except we don't have the y-intercept in the table. Let's just go ahead and put that in there. Y-intercept is 0, negative 39. Okay, now we've got everything in the table. We've got everything in the graph, but we have not said anything about the equation. So this is factored form. This is the factored form of the equation, and it shows the x-intercepts. So this is my factored form. It shows my x-intercepts. I'm going to rewrite this in standard form, which is going to show me my y-intercept. So to do that, and this is where we kind of started running short on time, I'm going to multiply x minus 3 times x minus 13. That's going to give me x squared minus 3x minus 13x plus 39, okay? So that's going to give me that negative 1 is still out in front of everything. X squared, I'm combining like terms. I'm combining negative 13 and negative 3. And then plus 39. Whoops. So all I did, I know that was off the screen a little bit, I just multiplied x minus 3 times x minus 13, which gives me this. This negative 1 is still going to reflect it. It's going to flip it over. So I could simplify that a little bit further and write that as negative x squared plus 16x minus 39. That is standard form. So you do have to do some work in your notebook and send me, you're going to need to send me the link for Desmos, and you're going to need to send me all of this because there's just, I can't see how you would type all this in Illuminate. Okay, the other form that we're going to use, standard form shows, isn't this our y-intercept? So standard form shows the y-intercept. Okay, and then the other form that we're going to use is vertex form. And vertex form is right over here. Okay, vertex form looks like this. And we did some of this work when we did completing the square intro. Solving these two Khan assignments are related to changing it from standard form to forcing it to be a square. So the first thing I'm going to do is I might just leave that negative there, but I am going to move this 39 over and just give myself some space. So I'm going to write y equals negative x squared Okay, I'm going to try and make this as simple as possible. So I'm actually going to start with this form right here. Let's start with that. So that was negative x squared. Let's do that. That'll just be a little less confusing with that negative there. So let's do this. So negative 1 x squared minus 16x plus 39. Let's not even worry about this negative 1 because we didn't do any with a negative coefficient. And let's just work on this part right here and forcing it to be a square. If we were to write this in vertex form, we need to complete the square. That's how you're going to go from standard form to writing it like this. Okay, so let's write x squared minus 16x, and let's put this in brackets. This negative 1 hasn't disappeared or anything. I'm just not going to distribute it. I'm just going to leave it right out. It's going to be, let's see, I think I have another card for vertex form. That is going to be this a value right here, just like it was in factored form. We figured out that this had to be negative 1. Same thing here, and we're just going to have a as negative 1 out in front of the entire equation. Okay, so I'm going to move 39 over a little bit because I'm going to add what is going to force x squared minus 16 to be a square. Okay, so if I want this to be a square, I would put 8x is here and 8x is here. It's negative 16x, so I'm actually putting negative 8x here and negative 8x here. And I realize at this point I'm probably losing some people. If you can only do up until this point, you're in good shape. But if you can maybe pause the video, take a little break, come back to it, try to finish it, we're almost there. We're almost done. Keep up the good work. This is not easy. Okay, if I was forcing this to be a square, this would have to be 64 for it to be a square. So I'm going to add 64. Now this is an equation, and when we did this with Khan, we added 64 to one side, we added 64 to the other side. I could do that here, but I'm going to wind up subtracting it from this side. And I realize this part may be a little bit weird because we didn't do it like this on Khan. But this is a legal move. If I add 64 on the right side and subtract it from that same side, I'm not changing the equation. It's the same as adding 64 to both sides. So one strategy for forcing this to be a square is to just add it and subtract it from the same side. Okay, what I did is I made a square, which allows me to say what this is in a different way. So I'm going to rewrite x squared minus 16 plus 64, which is what this is right here, as a product. As a product, it is x minus 8 times x minus 8, which is x minus 8 squared. That negative 1 is just out here in front. You know what? Let's not even worry about that yet. Let's just get this figured out. I do need to combine these. That would be positive 25. No, negative 25. No, positive 25. And then this negative 1 is still out here in front of everything. That is vertex form. Now, the vertex is 8, 25. And you can see the vertex in vertex form. Vertex form is called that because it shows the vertex. Okay, so you could go a step further and distribute that negative 1. That would give you, I'm still gonna put it in front of the parentheses. That would give you negative 1 times x minus 8 squared, and then negative 1 times positive 25 is negative 25. So there's, wait a second. That's a negative 25. Whoops. Hello. And then it turns into positive when I distribute the negative 1. Okay, there we go. Positive 39 and negative 64 is negative 25. Distribute negative 1. So my vertex is seen in vertex form. It's 8 and 25. And if you type in this equation, okay, so you got vertex form. You're doing that by completing the square. You've got standard form. If I type in all 3 of those, here's the vertex form. I'm going to type in standard form. And they overlap. They all overlap because these are all the same equation. The black is standard form, is vertex form. The red is standard form. And the one we started with was factored form. And I think we're done. We showed how to see the x and y intercepts in the table, and in the graph, and the equation, and that